Alright, how much progress do we have made through homework 4 so far? How many have gone through half of it at least? Okay, not so many. So then we need to spend more time on homework. But before that, I'm going to tell you on vectorization in MATLAB. Part of it is also involved in homework. But you have already done a lot of vectorization so far in this course. Let me just make sure that I haven't missed anything about while loops. There's one thing about while loops. Sometimes you might make a mistake and you forget, for example, to put a condition properly inside your for loop or while loop. And then this, especially with while loop, it's going to go for infinity, forever, and it will never stop. The solution to such cases, in order to stop the while loop, is to press Control plus C. That will break the while loop for you. So I say while true, display, this is insane, okay, and end. And it's going to print insane forever. You cannot stop it, right? So the solution is to just press Control C. So what happened, I said, oh, again, I did it. So I said while true, display this message. So what does this mean? It means so long as this value, this logical value is true, which is true, right? So it's basically the definition of true, right? Display this message. So this loop will go forever. It will never end. And the solution to end it is to just press Control C if you make such a mistake. It can be more complicated. For example, here you could have something mathematical, a mathematical expression, but again, it is never false. So your loop doesn't end. For example, you say if I don't know, if I is a complex number, right? So you could test it for complexity, like if it's a complex number or not, and then it's always true. And you don't know, if you forget that I is a complex number in MATLAB, then you might be in trouble, right? So that's about it. And then there are also two other functions that are really useful in MATLAB. So let's say I have a vector D. Let me see if I still have it here. Yes. So let's define this vector D. And then I say if D larger than 0, then display some positive numbers detected. You could create this vector for yourself just by putting random numbers there. It doesn't matter. The specific values doesn't matter. All you need is to have some negative values and positive values. And then I say end. So what do you think this will display for us? This if block. Will it display anything or display nothing at all? Yes. It will display the string. If D is larger than 0, I suspect it will not, but we'll see. What happened? Yeah, it did not. So what's the reason then? What do you think happened? Yes. Is it what? It does look at every element, but it does something more easily that you're not the barrel, and you have to be really careful about. And you have seen this, of course, in the past, but maybe not explicitly discussed it. So what's really happening is that when I say D larger than 0, what does it do? Can anyone tell me? We've done this a lot before. I told you that D is a vector. It has some values in it, right? It has negative 0.2, 1, 1.5, 3, negative 1, 4.2, 3.14, right? So it's a vector of real value elements, right? And now I say D larger than 0. What's going to be the output of this? False.
Vector of 1 through 0.
Excellent, yes. It gives you a vector. And false and true, yes. So this is what it gives you. So let me redefine again. This is D, and this is what I said. So if I say D larger than 0, it's going to evaluate for each element whether the element is larger than 0 or not. If it's larger than 0, then its value is 1. So for example, for the first element, it's less than 0, so it's false. The second one is larger than 0, it's true. True, true, and then -1 is not larger than 0, so it's 0 again, right? So basically when we say if D larger than 0, we are putting a vector of false and true statements, true values, in this logical statement. And now can you tell me what's happening really here with this if block that we wrote? So let me bring that if block again. This is the if block. Again, it doesn't display anything for us. So D larger than 0 is a vector. It's not a single logical value. So what's happening really here? And it has true and false. Exactly, yes. So what's happening is that MATLAB hiddenly and implicitly puts AND operator between each element. So that's something, that's a assumption, convention in MATLAB that you have to keep in mind when you're using a vector in logical comparisons, right? So whenever you have a vector of true and false, and you use it in if block, MATLAB puts AND operator between each element. It says if the first one is true, and the second one is true, and the third is true, and the fourth is true, fifth is true, and all of them, basically. So this would be equivalent to saying if all D larger than 0, then print something for me. So if D larger than 0 and all D larger than 0 are basically equivalent to each other. Okay? All is a function, again, is a logical function in MATLAB that checks if all the elements evaluate a true value in a vector. So if I say all D larger than 0, it's going to give me false, right? Because not all the elements in D are larger than 0. So this is D. Now, what is the function for OR? What do you think should be, given that all stands for some is good, any is better, yes. So I would say any D larger than 0. What's the output of this now? If any of them is true, then it's true, right? So now if I say if any D larger than 0, then display this message, then end. I print something for us. Okay. So again, D larger than 0, it gives you a vector, but when you use it in an if block, it evaluates MATLAB hiddenly and implicitly puts AND operator between each element here. And it says if all of them are true, then do what you have requested in the if block. So D larger than 0 in an if block, like this, is equivalent to putting all here, right? So if you want to get a single scalar value in if block, you have to always use all or any. Otherwise, you get a vector of logical values, and then if block in MATLAB implicitly puts an AND operator between each value and makes your life much more difficult to debug. Okay. And then with the while loop and for loop, I told you can always use break and continue, right? So what does continue do? If you have continue keyword in a for loop, for example. So let me show it with a case. So I say for I equals 1 to 10, continue display I. What is this doing then? What do you think the output of this would be? Nothing? Something? Just one figure? 1 through 10, all of them? Okay, we'll see. It does nothing actually. Why is it so? Yes. So it's all because of this continue statement here, continue keyboard. When you say continue, wherever it is, it goes back to the beginning of the for loop and it starts over again. But we don't do anything between the for loop, between the header of the for loop and continuous statement. So basically we don't do anything. It never reaches this statement. It hits 10 and it gets to this statement again, the continuous statement, and it says go back again. It goes back and I is 11, so it doesn't do anything. It just quits the for loop, right? Yes. Here is nonsense, redundant, right? Just to show you that what continue can do for you, right? So if you wanted to have it correctly done, so you would say for I 1 to 10, display I, and then continue a statement, and then end. But then again, what's the use of continue here? It has no use, right? It's just redundant. You don't need it. Most often you need continuous statement where you have a condition happening inside of your for loop. So for example, something becomes positive or negative or infinity or another number, and then you say, don't continue anymore. Go back to the next value of I and start over, right? So if I do this, it's like I don't put continuous statement here. So continuous statement in this example is all redundant. That's everything for us, right? And then you can also use break instead of continue wherever you want to quit the for loop entirely and don't do anything more, right? And you should always put an end to every while statement and for loop. You know these things. And then now let me tell you a little bit about vectorization. So what I'm going to do is to create a vector that has a length of 5 times 10 to the power of 7. What is it? It's 10 million, 50 million elements, right? And rand n, as far as I remember, it creates a set of normal, so let's see, doc rand n. I think it creates, for normal is normal distributed, okay. But I think it's a standard normal distributed, yes, okay. There is also another one, norm RND, I think. Yes, okay. But norm RND is slightly different from rand n. So rand n creates a set of normally distributed values for you. I will tell you what normal distribution is. But let's create it first. So x is, so n is 5 times 10 to the power of 7. So it's 50 million. And then I say x is equal to 50 million random numbers from the Gaussian distribution. Standard Gaussian distribution. So it takes a while to create it. Right. Now I just want to show you what x is. So I say histogram x. I want to create a histogram of x just to show you what we are working with. So this creates, this is really amazing. So with 50 million random numbers, you get a histogram that looks like this. If I now said, that hurt really, so if I say x 1 to 100, what do you think I will get? I would say, so you have this nice looking smooth histogram here, right? And now if I say plot only 1 to 100, you're going to get, no lads, it's just 100 values, and it's going to look really rough. You see, that's how it looks like. it still looks like a normal distribution. It's a bell-shaped distribution, but it's not as smooth as the previous one, right? And as I increase the number of x, you get better and better estimates of the normal distribution. 10,000, you see, it now looks pretty much like a Gaussian distribution. And if I make it 100,000, it looks really nice, right? So now if I make it 1 million, and then if I say 50 million, which is the number, it's actually more. 10 to the power of, I think this is correct now. Yes, and that's what we get. So let me see, I forgot, length of x is 50 million, yes. No, we could even go one digit further, so we could say, plot this. This is the final, the total elements, all of the elements in x. Okay, but that was not the point of the discussion. I wanted to show you something about vectorization. Now, let's do this. So I have this x vector that has a length of how many digits? I don't know. 5 times 10 to the power of 7, right? It's really long, and I wanted to write another vector. So create this x value and also the n. So write a script that has this value n, and it creates an x vector that contains random, standard, normal, distributed values that has a vector size of n and one column, n rows and one column. Okay. Now, once you do this, I want you to write. So let me put this in a script, just like you want to do now. And then I say, go to the end, and then I want to write a for loop that checks whether the value of x is positive or negative. So I want to create another vector called logical x, or maybe I will just put it, whenever I have a vector, I tend to capitalize the first letter so that I know I'm working with a vector. So I will make also this one capital X. So capital X is rand n of this size. Then logical x is zeros of the same size as x. Okay, so what is this one doing? Zeros of size of x. Creates a zero matrix of the same size as x, right? Now I want to create a for loop that goes through each element in x and checks if it's positive or negative. And if it's positive, it sets 1 in logical x, and if it's negative, it does nothing, right? So it just remains 0. Okay. So I would say for I. So let's write it yourself and see. So we're going to write a for loop here that sets the logical x to 1 wherever wherever x is positive, x is larger than 0. So you will have to have a for loop and an if block, right? So you'll have to write a for loop here, and inside of this you will have to write an if block. So now you have to fill in the required empty spaces in the for loop and if block. It's really easy. Then once you do it, I'll tell you what to add to this script, because I want you to time the performance of your script. If you you did it, then let's put it in. Once you do it, I would want you to put these two keywords, tick and talk, at the beginning and at the end of the for loop. And then this should give you a number. And then tell me what that number is once you've done. By the end of this for loop, your logical x should be a vector of zeros and ones, because some of the values of x are positive, right? So for those positive values, you should have, no, not all the values are positive, some of them are negative, okay, right? No. It's not a random number between 1 and 50 million. It's 50 million random numbers, each of which is between positive infinity and negative infinity. But most of it is concentrated around 0. So let me show you the histogram again. See, this is the histogram. The mean of all of the random numbers, so the average value of all the random numbers is 0. But the set of 50 million random numbers is distributed around 0. So it goes from, most of them fall between negative 4 and positive 4, right? But there could be values higher than that. Yes?
What are they gross here? Did you put in?
No, that's the definition of normal distribution. So when you say, I want a standard normal distributed random variable, you're saying, I want a random variable whose distribution follows the normal distribution with a mean of 0. That's a standard normal distribution. And the mean width, the width of this distribution is 1. So basically, 1 on this side, the average width of it. So the width from here to here is about 1. And here to here is about 1. But it doesn't mean all of the numbers have to fall in this negative 1 to positive 1 region. It can go to infinity, but the likelihood of falling in those regions outside negative 1 and 1 goes to lower and lower values as you move away from it, right? So you have actually coded this before in your homework 3, I think. I asked you to write a norm PDF. You remember? The norm PDF is the function that gives the shape of this function here, this distribution here. So in your next homework, I will ask you to get a plot of this histograms using norm PDF or your own vision function. Okay, so we have 50 million numbers. Don't confuse it. And then once you're done, you should get a number from this tick-tock, and then I'll tell you what that means. But when you get it, let me know. You don't need to put Instagram in your code. Don't worry about it yet. But if you want to know how you create it, that's called histogram. That's all what you need to do. So you say, we'll get to this next week, but for now, if you want, or maybe this week even, just say histogram X. Okay? And then it creates the histogram for you. Right? But for now, this is just for fun. You don't need to worry about this. Write a for loop and then if block that sets the correct values for logical X. So has anybody got the number yet for TikTok? Still running? 0.762, okay. That's fast. So I don't know why yours has taken so long. Because if his code takes 0.7 seconds, then yours should take pretty much the same. Okay. So let's see what we can do. For I equals 1 to n, if xi is larger than 0, then logical x equals 1. Not logical x, all of it. Did you forget to put the index for your logical x vector? Because that can make it really take so long. So this is the correct way of implementing it. Did you all do the same way for your code? Okay. So now if I save this, talk first. Okay. Now I want to run this code and see what we get. Change folder. Okay, so on my computer it took 1 second and a fraction of a second, which is not important. Okay. And 35 milliseconds basically, 36. So has anybody got any other number? 0.9. Okay, yours is fast as mine. 0.7. Okay, 0.7, 0.6. I want you to run again your code and then see if you get a smaller number or not. I bet you should get a smaller number. Okay, yes, exactly. And I'm going to show it to you that I will also get a smaller number, hopefully. No, okay, I didn't get it. So the reason is that you have to keep in mind, whenever you want to time the performance of your function, there is always a first time cost when you call your function for the first time. Okay. Because MATLAB needs to load the function and then read it, understand it, and then do what you want. But the second time, it takes much less time for MATLAB to prepare your function and do, or a script, and do what you want and time it. So if you want to time your code, you should always run your code first time and then run it another time to make sure that you get the correct answer. Because the first time call has a hidden cost. Okay, so it makes your function slower if you try it the first time. Now for the second time, here's the thing. So we've got this number. Now we want to do it in a smarter way. Hopefully it will give us a better number for the performance of the function. But let's try it. Now we want to do this in a vectorized way. So we have again n, x, logical x, which is this. But instead of the for loop, I'm going to do it this way. I say logical. I don't even need the if block. So I say logical x, wherever x is larger than 0 equals 1. Simple as that. So now compare this code. Let me save the file, TikTok2. So compare this code to what we wrote here. See, it's much more concise when you vectorize your code. Basically what we are doing, can anybody explain what I'm doing here with logical x, x larger than 0 equals 1? So you remember I told you whenever you have a vector and you make a comparison, logical comparison on it, then you create what kind of species you create, what kind of object you create when you compare a vector with some number. What was that? Yes, Boolean, but what is the length of that Boolean? 50 million, yes. So when I say x larger than 0, I create a vector of size 50 million, each of which is either 0 or false, 0 or 1, right? True or false. Okay. So basically, I would not even need this logical. Well, yes, sort of. I mean, basically, we have our answer by this, but we want to put it in the logical x vector instead of having it in the answer MATLAB default variable ANC answer. So now let's run this one. So write this code yourself, and then let's run this one and see how long it takes. Hopefully it should take less, but we'll see. I have still a little bit of doubt that it might take a comparable amount of time or even more.
When you say logical x greater than 0, it should be now if x is less than 0 and it's false. Or is that just
because, yes, Because you see, that's actually hidden here. So we say logical x, we initiate all the variables to 0, all the values to 0, right? So we assume that everything is false. And we just set those values to positive, to 1, where the value is specifically positive, right? So we don't need to worry about the false, the negative values. So we only care about the positive values, right? So now if I press 1, it takes 66, basically 0.66 seconds, which is, you see, compared to this one, it takes up almost about 1/2 of the original, right? So if I run this again, 65, 68, okay. Every time you get a different number. Can somebody explain why? Exactly, because the processor, you cannot hear it, but I can hear it myself here. It's doing a lot of other works. Probably Windows is updating or doing something else. So if I press Control Shift Escape, you can see the performance of the computer. So CPU is used by about 50%, and then there's also a heavy usage of memory. So there's a lot of other things that are active right now. So all these different applications, right? So if I order them by CPU, probably the culprit here is Minicam and then Zonar, whose job is to secure the computer. But I hope you get the message now here with this example. You notice that this is called a vectorized code, meaning that I avoided typing explicit for loop or while loop by just using the vectorized syntax of MATLAB. Some languages have this syntax, like I think Python also has it, and then, but through libraries, not Python standard. And then Fortran has a standard syntax for this vectorized code. Actually, MATLAB inherits it from Fortran. But here's my question: why do you think the for loop version of this code takes much longer than the while version? The vectorized version of the code. What does the vectorization do in this script that makes it much faster, almost twice faster than the for loop version? Yes.
I don't have an answer. When I run it vectorizing format every day,
Yeah.
For running a different way, it's faster. I don't know why. It happens.
So what change did you make to it?
I just made multiple x equals x more.
Yes, basically. That's a very good point. Yes, we could actually make this smarter. We don't even need this.
Well, when I write it the way you had it, it's significantly slower than the for.
Really? So mine is, so let's try it again. Because, so this is the way I had it, which again, the way you coded it is smarter than this one. But let's see what happens. So if I run this again, gives me 0.66 seconds. If I run the for loop version of this, it gives me 1 second. Okay. But now let's try. I forgot your name. What was? Yes. Fahima? Fahim. Okay. So Fahim says, let's do it this way. Logical x equals x larger than 0. What's the difference here then? I think this one should take more time, I would say. But let's try it first and see if it takes longer or not, and then we can discuss it. Oh, it's actually much faster. Okay. So why do you think it takes less then? I knew this, and that was my original suspicion why I told you that this vectorized code might take longer. And the reason, my worry was that when we are calling, when you are saying logical x, let me go back to my original code. So, not this one. Okay, this one, the original code that I had. When I say logical x, x larger than 0 equals 1, what I'm doing is that I'm creating a vector of x larger than 0. So I told you, when you make a comparison of a vector with a number, then you create a vector of the same size, right? So MATLAB has to save the values for this vector somewhere in its own memory. You don't see it, but it saves it somewhere for you. And then it says, I have another vector, logical x, and I want to set specific values of it corresponding to this vector that I have to 1. So you're doing some work redundantly here. You see the point? So there is repeated work here. You create this logical vector, but then you create another logical vector that uses that logical vector that you created implicitly to assign values to it, right? But with the way Fahim said, we are skipping this step. I'm saying just put the logical vector that we get from x larger than 0 directly to logical x without any further calculations. Because of that, I'm surprised. The only thing that surprises me is that we get almost like 20 times faster code compared to the original code that I wrote for you. This is really fast. Okay, thanks, Fahim, for that. Yes?
When you do it that way, you don't need to reallocate by making 0.
Exactly, you don't even need that anymore. I think you won't need, yeah, very good point. You won't even need this. So you can even make your code more concise and faster. So this is the original code that we wrote, which is really, in my sense, dumb, because you can do it in a vectorized way. Very lengthy and slow. And here is the vectorized version of it in just one line. Okay? Yes?
How much time does it take to run TikTok? How much time are you wasting?
Oh, so good question. But the TikTok is really fast. What it does is that it goes and reads the time in MATLAB in units of, I think, microseconds. And then whenever you call, so that was a good point because I didn't tell you anything about TikTok. So this is basically a stopwatch. When I say tick, it just clicks the timer and sets the timer for you. And then when you say talk, it clicks the timer again and it gives you a time, the elapsed time between the two, between tick and talk. Now you could apply talk again here and see what we get now. So let's run this. You see pretty much the same numbers, right? It doesn't make much of a big difference. So the talk function doesn't really spend a lot of time and cost you a lot. It's about like 1% of a second. 0.0, it's about 10 milliseconds, okay, compared to this one. Do you see how I calculated it? Is it clear? How I calculate the cost of talk? So I say the talk, the stopwatch for this logical x is this one, is this number. And then the second talk gives me the second stopwatch number, which is this. And the difference is about 10 milliseconds if you compare the two. Right? So talk function, based on this, I could infer that it's probably going to take us, it's going to consume only 10 milliseconds of our time, not more than that. Which is not significant when you're testing the performance of a really huge code. Doesn't make much difference, right? So keep in mind, you can always avoid for loops, almost always, not always, but most often you can avoid it, especially while loops. While loops are really slow in any language. So you should try to avoid for loops and while loops. But why do you get such a huge difference? Can somebody tell me why vectorized code is much faster than a for loop? Yes? That's right, yes. So what's happening? If you did this probably like 40 years ago, you wouldn't see much of a big difference. You would not even be able to do it in a vectorized way. But over the past decade, computers have become really capable of doing things simultaneously for us. So what happens is that these CPUs that we have in our computer, they can take big chunks of information from the memory and then bring them to the CPU, do the calculations that you want, and then put it back in the memory. Right? when I say for I want to n perform this calculation that I want, like this one that we have here, for I want to n, I'm asking the CPU to go to the memory one by one for 50 million times. Go back to the memory, get one element which corresponds to one value of x, so xi, get it, and then bring it here, do the calculation that you want, and then go back, put the logical value, vector, logical x, back in the memory. Okay, so you set it to 1, right? The point is that the time it takes for the calculation of this vector is almost nothing in CPU. Most of the time that we spend in calculations is the cost of going back and forth between the memory and the CPU, right? So the new trend in scientific computing right now is to minimize this cost, the cost of data transfer from the memory to the CPU. What's the solution? Each CPU has its own memory. So I don't know if you have heard of L1 and L2, L3 cache. Have you ever been? Yes. So memory in a computer is structured like this. So you have L1 memory, then you have L2, and then you have L3, and then you have the hard drive, the one that you store everything in it. That's wherever your files are stored, right? This one, L3, has another name. Do you remember? You can somebody tell me. We have direct access to this one too. Almost direct access. Anybody remember? What is it called? RAM, or random access memory. So each one of your computers, let me show it to you on my own computer. So if I go to my computer here, the task manager, under memory, I have 16 gigabytes of random access memory. That's this one, L3. So I have 16 gigabytes here. And for this one, I have about 1 terabyte. Okay, but the point is that CPU, it will cost a lot for the CPU to access each one of these. And the hierarchy also holds for the cost of call. So if CPU calls this one, it costs it just a little bit. If it calls this one, if it takes data from this level, it's going to cost it a lot more. And if it takes from L3, it's the slowest one. And if you take it from the hard drive, it's going to be the slowest of all, right? So if you could put your data in the L1 level in the memory, then that's going to be the fastest way. Now, people have been working really hard to make these L1 levels really big, as big as they could, but these are really small still, so it's on the order of kilobytes. So like, for example, for this one, we have 64 right now. Okay, or times of 64 at most, right? So what's happening in this when you try to vectorize your code is that instead of going to your the RAM memory, which is really slow, and get each one of these elements one by one, going back and forth for each element, you tell MATLAB, go get as much as you can when you try to vectorize it. Go get as much as you can and bring it to the CPU, do all the calculations that you want, and then put everything back collectively into the memory, right? So you don't go back and forth as many times as you go when you use for loop, okay? So that's the difference between a vectorized loop, a vectorized calculation, and a for loop calculation. So with the for loop, you need to go back and forth, and with the vectorized loop, the vectorized code, you try to minimize that back and forth between the CPU and the memory, right? So if I ask you in the quiz next week, what's the difference between the vectorized loop and the for loop, then you should be able to answer it, right? Because I explained it for you. Is that clear, or you still have questions? No? Somebody shook hands. So I'm shook his head. So that means it's probably communicated.
So does it grab all the information?
That's a good point. So it can grab as much as it can hold in its own internal memory, L1 level. right? So it can bring as much memory as it can that can be stored in this highest level.
So you can say like it takes more of these. It takes more at a time.
Because these memories, these two top levels are really small. They cannot hold all the information that you have in X. X is 50 million elements, right? So it's huge. You cannot put it there. So all of this information are stored in the RAM, in the random access memory. Most of your computers probably have 4 gigabytes or 8 gigabytes or something like this. You could press Control Shift Escape and then go to the memory section, and then you can see it just like what I have here. So you can see how much you have. For my case, I have 16 gigabytes. Okay. So all the variables that you define, everything that you do is mostly done in this section. But whenever you want to do a specific calculation with CPU has to first bring those information into these two levels and then do the calculation that you want and then bring it back to the memory. And then you can output it to save it on the hard drive that you have. Okay? So, but these ones are limited. They actually have gold in them, so that's why they are really fast. And they are expensive, so you cannot build a lot of them because they are so expensive. And that's why one of the reasons they want all your electronic devices to be back to their own factory, because it has a lot of valuable metals that they can recycle and use into the computer. So that's why you shouldn't throw your laptop into the trash can when you're done with them. So these two are really small. I'm not sure about this number, but it's basically chunks of this amount, like 1 64-bit or 2 or 3 at most. So L1 is the smallest, but the fastest. L2 is the second smallest and a little bit slower than L1. And L3 is the biggest one and the slowest. And then you have hard drive, which is the slowest of all. Right? So most programs work with this. It stores information, variables here. And then if CPU wants to work with them, it goes to L1 and L2 and asks the computer to bring the information from L3 to L2 and L1. And then does the calculation here and then sends it back to the RAM memory. Random access memory.
In L1 for the i7 chip, it's 64 kilobytes.
64 kilobytes. Okay, so this is probably, I told you, this is chunks of it. So it's 64 kilobytes, not bits. Okay. So again, the reason vectorized code is faster is because it brings chunks of information into this one and then puts it back to the CPU and then brings it back. Instead of doing one by one calculation. I'll see you next time.
Professor, what time are your hours today?
4 to 5.